Hello friends, let's talk about consistent hashing today. Consistent hashing is an efficient load balancing technique in distributed systems. Let's start understanding consistent hashing by understanding the simple hashing, and then we will evolve our ideas to consistent hashing. What is simple hashing? Simple hashing is the load distribution based on the hash of a key. Okay, so let's say you have a server serving the requests, clients are sending the requests to the server. Those requests needs to be served by various servers, and so what simple hashing does is it takes the it parses out the key from the request, incoming request, and uh, and then distributes it among the servers based on some criteria. What is that criteria? That criteria is can be as simple as some arithmetic such as y equals x modulo n, where x is the hash of the key and n is the total number of servers in the system. And so in this way, the value that is generated that represents the server number. So that particular request gets routed to that server, to the server y. And so in this way, the load balancing is achieved using simple hashing. What are the disadvantages of the simple hashing? So there are a couple of disadvantages of this mechanism. One is the addition or removal of servers. It mandates a costly operation of remapping of all keys. So addition or removal of the servers is rather a relatively frequent event. Okay, a particular server can easily crash in a distributed system, and that mandates you to remove that server from the system in order for the requests to not route to that server. Or let's say the system scaled. Let's say you see a spike of traffic in your system, and so you need to add a new server. So you need to consider that server into you need to increment the value of n in your modulo function in your arithmetic in order to serve the traffic to that server. And so in order to do that, you need to remap all the keys. You can no longer continue to use y equals x modulo n, because it's going to yield a different value with different n. So you cannot use. So you have to remap all the keys to different servers. So you have to move around all the keys, which is and the number of keys can be in millions or billions, and so this can be a very costly operation. So that's the first drawback: addition or removal of servers, which is the change in the value of n that mandates a costly operation of remapping all the keys. And another drawback is the potential to create hotspots depending on the key frequency. That is, if a particular key is being used a lot, then that's going to allocate traffic to a particular server. And this can happen in two instances. One is a particular key is being used a lot. A particular primary key is being used a lot. A request is being generated a lot using that primary key. That is the first reason. And another reason is the hash function. The hash function, even though the requests are equally distributed among all the keys, the corresponding hash function that gets applied on those requests, they yield the same value. And so you have the hotspot created for the servers serving those values. The solution to these two problems is consistent hashing. Okay, what does consistent hashing do? You can see on the diagram on the right, well, the bigger circle is the entire range of the hash values of the keys in a circular fashion. And then the number of servers, all the servers are distributed in the entire ring format. Let's say in this instance we have four servers. And so there are various quadrant data ranges that are formed in all the possible values. And what this technique does is, whenever you have a value that is generated in any quadrant range, the next server that appears in the clockwise direction in that path, that server takes that request. So in this way, a fixed one-to-one mapping is developed among the request IDs and the servers. What this does is it alleviates the problem of remapping the keys since the addition or removal of servers simply transfers a portion of load to the next server in the ring. So let's say server 2 went down here, and the key value that gets generated in between server 1 and 2, right here, it gets processed because server 2 is down, that gets processed by server 3. Okay, and you can have n number of servers here. Okay, and so the load is taken by the next server, so you don't need to remap all the keys. You can, well, that's not entirely true. You need to remap only those keys to the next server. You don't need to remap all the keys, and so so it alleviates the problem of remapping the keys. However, there is hotspot problem. Consistent hashing in this version doesn't resolve the hotspot problem. What does it mean? It means that all the requests, when they get mapped to this particular quadrant, consistent hashing, server 2 is overloaded. Consistent hashing doesn't solve that problem. So the requests can still get mapped to any particular quadrant, and that particular server gets overloaded. So the solution to the rescue is consistent hashing plus vnodes. Okay, so in this diagram, you can see that what we do is, I have represented these arrows with the colored arrows as a smaller sub-ranges. So I have this entire circle of a big range of the key values. And so a really big range of the key values is divided into smaller portions of the sub-ranges. And so those smaller portions of the sub-ranges I have marked as in those colors. And so what happens here is that each sub-range is called a vnode. Okay, and in this technique we allocate a particular different sub-ranges to a server. Okay, so in this case we have these different, the two red marked red sub-ranges, they are allocated to one server, and you can also imagine similar sub-ranges on this side of the circle. Okay, so we have, let's say, two red sub-ranges from these two quadrants, and then two red sub-ranges from these two quadrants, they get allocated to one server. And similarly, server 2 takes up the green sub-ranges, server 3 takes up the blue sub-ranges, and server 4 takes up the yellow sub-ranges. And so what this does is that it alleviates both the problems. The load balancing, because when the server 1 goes down, the next server takes up the smaller sub-range, right? It takes up all the traffic, right? And so when the server goes down, you don't need to remap all the keys. You just need to remap only those sub-ranges from server 1 to server 2. And similarly with the addition of the new server, all the other servers, they give up some of the vnodes, some values from the vnodes to the new server, and only those vnodes needs to be remapped. So in this way, it alleviates the remapping problem, load balancing problem, and the other problem was the hotspot problem, where this consistent hashing plus vnodes also alleviates the hotspot problem, which is because the size of the subrange is extremely small, so there's no way it can create a hotspot. Even if it creates a hotspot, it creates only in that subrange, and even that subrange is served by many servers using replication. And so in this way, it solves both the problems. So here I've explained the exact same thing what I just spoke. Any comments, questions, or feedback, post them to the video, and thanks for listening.